In this tutorial, we want to look at the possibilities of display control for the 3D display for the 3D mapping. I have a created project in here, loaded a textured surface model, and now every time a 3D model is loaded, I have this toolbar for the 3D display control. At the beginning, I have the two buttons, 2D and 3D, so I can always switch between the 2D for printing and 3D for mapping. Next to buttons, I have the option to activate a two-window display. That means I can see my 2D display and my 3D mapping at the same time, and I can always control and double check how the signatures are displayed in a 2D output. I can do this either vertically or horizontally, depending on the screen size or the object size. With the next one, I have the possibility to organize several views. And can switch back and forth between these while mapping. So I have to activate the respective window with a left click to map in the correct window. And then there is the VR function. It's hard to show in a tutorial, but here is the possibility to transfer the 3D display to a VR headset to look at the whole object virtually. Next comes the selection of the coordinate system. I currently have two coordinate systems here. First, the world coordinate system, in which the 3D model was calculated in the SFM software. Are there control points, or can I maybe organize this with a vertical distance? You usually get this automatically included with the model import. And then you usually want to create your own user coordinate system because you want to define a corresponding layout for your print output. As you can see here, you now have a vertical display defined in the coordinate system to create an unwrapping of the totem. So when I've selected my user coordinate system, I can then use the second pull-down menu to select the different 6 views. That is, I have the front view, YZ, the rear view of it. Then I have the front view of XZ and the rear view of it as well. And then the top view and bottom view. Now, for example, if I have chosen the front view here, I have the option to hold an axis with the next function. That means the rotation is limited. So I now choose to hold the Z axis. If I now activate the rotation with the right mouse, I can only rotate around the vertical axis. And if I don't want this anymore, I have to deactivate the button again. That is, press once to activate. I could use the arrow to select which axis. Press again, deactivate. I can move it freely again. With the next button, I can adjust the ortho projection. That means I have the function change projection mode and activate with a simple click. Orthogonal projection or perspective. Orthogonal projection is interesting for the 2D print display. That means orthogonal projection here is automatically activated. In 3D, you may prefer working with a perspective for mapping. Then we talk about the point of rotation. So when I move my mouse with a held mouse button, the object always rotates around the corresponding point of rotation. And I can initialize this rotation center. This is the function for that. That means I calculate the surrounding box around the corresponding 3D object, and the center is defined as the rotation point. And I can turn on the surrounding box here, and then I see it, and I switch it off again. And now if I want to move the rotation point center, I can do it with a simple left click on the surface. That means I'm going to turn this on the shoulder and double click here. And then I now see the center of rotation on the shoulder is defined, and I can now turn that nicely around the local center when mapping. And with the double click right, we jump back to the overall view display. I double right click, turn this here. And make my new point, double click left. Can turn it now around the head, double click right. So you can navigate your objects relatively quickly and always rotate your object for the corresponding area mapping. This display setting, double click left, so on what scale it zooms, I can define that in project settings. For that, I go to project settings in the menu. And here I have a tab view, and there is a custom display scale. And if I enter 1 to 5 now, apply, double left click, it always jumps to the display scale 1 to 5 on the screen. I have the button up here, 100%. Then the scale of the project is always applied to how is the project printed. In this case, that would be 1 to 10. And double left click is 1 to 5. This is not enough for mapping, so I always think about what size I want to map, and then I can see below in a gray program line the current display scale in this case is 1 to 1.3. So now I take the scale 1 to 1 and the menu, go to project settings, view, custom display scale 1 to 1, and apply. If I now choose double click left, then I again have the display scale 1 to 1 on my monitor. These two functions replace the same as the double click, so I just click with the corresponding command and put a point here. The next thing is the coordinate system display. That means I zoom out of here, get the coordinate system displayed, and if I don't want that, I can turn it off. And then we have the function of minimally surrounding cubes. And this is just to see how big the data area of my object is. Then I zoom in a lot. I can here now see the triangle grid of my surface model. So I see in which geometric resolution the triangulation is calculated. That is, of course, dependent on the point spacing as it was created in the SFM software. I switch it off again. Then next we have two ways to control the display. That is, in the first pull-down menu, I see the triangles and the corresponding texture settings. And in the second pull-down menu, I see the points and the corresponding texture setting. Now we'll deal with the triangles first. I can now go to the standard color here. Then I just see the triangles without color as if I were importing an STL file and a corresponding shading. I can set the intensity of the shading in the display options. I have the dialog 3D display options, and there I can switch the lighting on off in the tab and also define the strength of the shading. Of course, this is just as well applied to the color, texture 1, so this is independent of the corresponding texture setting. Now while I'm in the dialog, I can still define the background color, whether I want a white or a black background. And in the first tab, I have the possibility to enter this perspective, like the aperture angle of my camera or the perspective of my camera. So if I go to 45 degrees, I have a larger wide angle, and we can define that depending on the object, however you prefer. Now we turn off the display of triangles and activate the display of points. That means I only see the basis of my surface model and can also choose the dot color and see my colored model. This point display is sometimes interesting if you have a very large surface model, that you first load the object only as a pure point cloud, then create corresponding segments, that means subregions, and then carry out the mapping only segment by segment. So you are not forced to always load the whole object for 3D mapping, but you can also only edit subregions in piece, even with an older notebook, depending on what the graphic cards allows. So now I turn off the dots again and activate the triangles again. If there are data problems with the graphics card, we still have the option to control the texture quality on the right. That means I have here a surface model where the texture images were delivered for 1096, and I can now say put the texture quality down to half resolution. And then at the same time, I see how the memory requirement on a graphic card is reduced down here. And then I go here to 1000, and of course at the same time, when I look at the control point here, I see how the display quality deteriorates more and more. And when I go back to 4096, the data is reloaded again and I have the full resolution. The following functions relate to the representation of the back of the surface model. If I rotate in here to see it, then I can choose whether I want to show it with a certain transparency, color, the texture on the surface, also on the inside, or if I want to show without texture in this shade of gray. So the next three views deal with the representation of mapping, which I will show again when we make a tutorial on the topic of mapping.